Thanks a lot for the introduction, and thanks a lot to the organizer and everybody, like the volunteers who helped for this conference. It's really been amazing so far. And also a great thanks to all the people who contribute to all the Python open source projects that I've been using. And well, there's another disclaimer slide. I'm required to emphasize that this is just a hobby. It has nothing to do with my real job. I work in a machine learning lab of an online bookshop, and so some of this work is joint work with Daniel Kirsch, who is sitting there. So here's the problem. Why would we be interested in automating political party affiliation or political view or bias prediction? My motivation for this was that everyday media generate loads of text. And the question is, what should you read? So you could either just read what your recommender algorithm of choice suggests, or you could just read what your friends suggest in your social circle on Facebook. But that, you could end up with, following these rules, you could end up with a lot of the same information or views. That's the classical filter bubble problem. And in many cases, if you're just following your friends who happen to not be, to not be journalists, for instance, they don't check their sources, so you end up with a lot of stuff like you believe in chemtrails or reptiloids and that stuff. So the reason for me to look at these things was that unbiased opinions really need unbiased information, and you want to have a heterogeneous sample of all the news articles heterogeneous with respect to political views. So the project goal was really automatic detection of political views or affiliation, in general political bias. And then I wanted to sample text from an entire political spectrum. And ideally, for me, that was just like a fun project for me. I just wanted to have a news recommend that I kind of, split stuff into topics, and then within each topic gives me a range of different articles sorted according to, political views, say from left to right, for instance. So some working hypotheses that I had along the way were, it's a pretty simple one. Can we actually predict political affiliation from text? And another one that's almost the same is, can we predict political views from text? And by views, by political affiliation, I mean just party affiliation. And by political views, I mean more fine-grained things. And I will explain that in more detail later. And these two hypotheses are mainly motivated by the kinds of data that I had at my disposal. Some related questions that came up along the way are, what are some discriminative features that could potentially then be used for, having political experts check these models, or maybe just relating that to, things that people in political sciences know, or maybe use that for future studies, or for, if you read text yourself, something to watch out for. And another related question that came up was whether or not political power influences the speech content in some way. So here's the workflow, and it's super standard. You've probably have heard exactly that same workflow in, 20% of the talks that do data science here. And the reason why I did it that simple was just because, that's what you do first, right? I also tried more complex workflows and models, but they didn't really help in terms of prediction performance. So first I got some text data with labels. And I got two different kinds of texts. First, I got the texts of all speeches in the German parliament. That's called the Bundestag. And the labels for these texts are the party affiliation. Of course, you have, quite a spectrum of political views within a party, but for the sake of simplicity, I'm just using the party label here. And I'm just looking at two legislation period, the 17th Bundestag and the 18th Bundestag, which is the current one that's still ongoing. And then I also looked at party manifestos, so that's what parties write before elections in order to get elected, where they explain the policies that you want to promote in the next legislation period. And the labels that I've got there are, of course, the party affiliation too. But then, that's the second part of these analyses that I did when I stumbled over the work of the Manifesto project people, which is part of the Wissenschaftszentrum Berlin here. They have an amazing project where they basically took all party manifestos of all parties in many different countries for the last, 50 years or so, or even more, and they have political experts assigning labels to each single sentence in these party programs, or sometimes even sub-sentences. And they have a set of 56 labels, so it's a 56 class problem. And these labels are kind of hierarchically organized. So you have 7 different political topics, and within these political topics you have subgenres. So a topic could be economy, a subtopic could be pro-market deregulation, for instance. So yeah, these were the 2 data sets that I looked at. And then I just did some standard stuff with it. I cleaned the text, computed bag of words feature vectors, I trained a classifier, just multinomial logistic regression. I tried other things, didn't work better. And then what I actually wanted to use that for, I applied that classifier to text where I don't know anything about the label. And that, of course, I just did that to, well, for fun, to be able to read more efficiently news articles. But it's, of course, extremely difficult to evaluate. And there is a web demo for that stuff. So if you're, I'd actually be really interested in, I mean, yeah, of course, feedback on this web demo. But of course, if anybody gets interested in these data sets, which I really can recommend working with, because there is a lot of work that went into there, especially also the speeches of the party of the Bundestag. When Daniel told me about this data set, I was blown away, because you look at these, I mean, there are these, the German parliament has 4 people sitting in front of the parliament, and they take notes of everything that's happening in there. If somebody insults somebody, if somebody interrupts a speech, everything will be noted down with the name of the person who does it and what they say, and all this is made publicly available on their webpage. So it's really a great data set. And that, yeah, leads me to, well, the data acquisition part. So these are the protocols that I just mentioned. You can just, so in the first part of the project, I just scraped it from that web page, and I wrote a parser myself. And then at the Open Knowledge Foundation, through Daniel, I met Friedrich Lindenberg, and he's a Knight Fellow. He basically put a lot of work into structuring that data that the German parliament publishes. So there is an API from Offenes Parlament, that's a GitHub project. And there is a scraper that you can just use to get that stuff in a structured form. And the party manifestos, also those guys put a lot of work into making that available easily for Python. So there is a RESTful API that you can use for that. I just downloaded it from the web page, but the API is publicly available, and yeah, it's a great data set. And as I said, I only looked at German data, but there is data for all languages, really. I mean, not all, but a lot of languages. So yeah, data pre-processing, super standard. I just did some NLP stuff, the most basic things you can imagine: stemming, stop word removal, removal of the names of the representatives, so I don't overfit on them, removal of the names of the parties, for instance, and removal of speech interruptions like applause, these things. So anything that I deemed to be helpful for the classifier to overfit on, for instance. Yeah, and then I just transformed that into standard bag of words features. I tried unigrams to 5 grams. For more than 3 grams, I used hashing, all super standard, and then term frequency, inverse document frequency normalization. And then I just optimized all this stuff using grid search, plain exhaustive grid search, using nested cross-validation. So that's, throughout the process of this project, when I started, I didn't know about any other studies that deal with that kind of data. Now I know, that there's a huge body of literature dealing with that, but it's a pretty heterogeneous field. Many people come from disciplines that don't know about cross-validation, for instance, so many of the results seem a little bit too good for me, for my taste. So I found it really important to really put a lot of effort into this. This is actually like 80% of the work is just optimizing the pre-processing. So, and these are the results. So it's a pretty dense slide, so I'd like to focus on, there's a pointer. I'd like to focus on this one? Thanks. I'd like to focus on this part here first. So this is the results that I got from just doing nested cross-validation on the Parliament data. So I just, in the simplest case for nested cross-validation, you just have 3 splits. One part of the data you put aside for evaluation later. You never touch that during training. One part of the data you use for testing while optimizing your hyperparameters, the grid search stuff that I just explained. And then one part of the data you just train on. And this is when I do this nested cross-validation within the Parliament data. And I get, well, it's a 5-class problem here for the 17th Bundestag. We had the Liberal Party, the Christian Conservatives here. Those 2 were the government. And those 3 parties, the Green Party, the Left-Wing Party, and the Social Democrats were the opposition. And you can see that, well, I didn't plot the accuracy here, but the accuracy is also just above 60%. So it's above chance performance, but it's far away from anything usable, really. And, well, these are just the number of samples I had in this holdout evaluation data set. Yeah, so it's above chance, but it's pretty low accuracies. When I do the same, when I test on out-of-domain data, which is what I'm actually interested in. I mean, I want this model to generalize well to data where I don't have labels, where I cannot train on, so like news articles, for instance. And the only out-of-domain data where I can actually test how good I am is the party manifestos. I also did the analysis the other way around, but I'm not showing this here. So when I test on out-of-domain data, the party manifestos, the performance drops like really badly. And this is expected, it's a different data set. And yeah, so this is, I'll talk more about that in the next part of the presentation. So what can you do to improve that? What many people have done in the literature before, they just look at the binary problem. Germany has a multi-party parliament. But many countries actually only have 2 parties, so that reduces that to a binary problem. And I also did that here. I just reduced it to a binary problem by classifying into government and opposition. And this brings you, in some cases, pretty close to 90% also accuracy, which is not plotted here, just precision and recall and F1 score. So yeah, you can actually make the problem a lot easier. But and this is also in line with what some people found before, when you do out-of-domain testing, and out-of-domain here can also mean you just go to a different point in time compared to what you've trained on. Also here, the accuracy dramatically drops. And these are the kind of effects that I will talk about a bit more in the later part of the talk. But so still, it's the same effect. We do get something above chance, so it's usable for some kind of assistive technology, or for, I don't know, speeding up label acquisition with active learning, for instance. But it's not like you could really trust these results. So the question I had was, why are these predictions so bad? The first point here is that we don't actually know how bad humans are. There are some studies on that, but it's a difficult problem. And if you read texts, it's not always clear. I mean, I wouldn't have a good estimate for how good humans are, or just the spectrum of how good humans can be. So that's something that I really want to look into further. And as far as I know, the people at the Manifesto project, they are looking into this too. And the second thing, and that relates to the holdout, to the out-of-domain evaluation data. These manifesto texts are extremely short. It's really just a sentence, and in most cases, so 25% of the data have only 8 words or less, and 70% of the data have only 17 words or less. So that really makes the problem much, much more difficult. So to test whether the length of the text has an effect on the prediction, I just aggregated all the text in these out-of-domain data sets according to the political topic that the Manifesto project people assigned. So I haven't used these labels, the Manifesto project labels, the political view labels so far. Now I'm only using it to aggregating data to kind of denoise the text a little bit. And what you see here is that you can actually with decently long texts, I mean, it makes a lot of sense intuitively, right? You can actually get a lot better classification accuracies. You can get close to 90%. Or in some cases, like for instance, the left-wing party, you actually always get it right. That's, well. But of course also, so you have a lot fewer data points. So you only have per party, you only have one data point per topic. And you can, of course, in some parts of the project, I did something in between. So you can just increase the length of the texts, but that's always kind of arbitrary. It's also in line with what other people have found. But the length of the text has a huge impact on the classification accuracy. Now these are the results. It's just, that's all I wanted to show about this. So these are the results for the manifesto code labels. And it varies dramatically. So here I didn't have out-of-domain data because I have these labels only for the parody manifestos. And some topics like environmentalism, or pro-democracy, those are, well, you can play around with the thresholds to trade off precision against recall, but it's not that bad. Some other terms like Keynesian demand, I had to look that up, what that means, and I forgot again, I think, but it's related to economics. And so those are extremely difficult to predict. But you also have very few data points. And remember, these are extremely short texts. Here, there is no way there are ways, but I couldn't think of a sensible way of aggregating these, because you would basically then transform it into a multi-label problem. So to summarize this, these views or affiliations, political bias, can be predicted with above chance accuracy. It's not perfect, but it's, well, I would consider this, a baseline. And I would be really interested if anybody of you guys improves on that and how you do this. And also, it's possible to predict out-of-domain texts, but it's much more difficult, of course. And some of the challenges is that, well, out-of-domain prediction remains difficult, and short texts are extremely difficult to predict. Now, with the help of Daniel, and then later myself, I tried to put up some web demos just to kind of evaluate qualitatively whether that stuff is any helpful at all. And the idea was just to expose classifiers, and then also to have some news, not recommendation system, but it just basically crawls all major German websites for news websites, and then it does some simple topic modeling. Also here, I tried every topic model, and also like nonlinear manifold learning stuff for structuring the text somehow. In the end, I used k-means because it just worked best. And this is a screenshot of the first demo that Daniel implemented, and here you can just put in some text, and I think it was something representative, something easy. So yeah, it says, reiche Banken und Neoliberale gefährden den Sozialstaat, which means rich banks and neoliberals endanger the social state, or something like that. And here you can also put in just a URL of a web page, the text of which you want to analyze. And then you click analyze, it dumps it in the classifier, and out you get a party affiliation prediction, which would be here mostly left-wing party, then social democrats, and then Green Party and Christian conservatives. Well, it's pretty straightforward. You can also apply this classifier then to news data. And here, it's been a while since I took this screenshot, but the idea is just that, so here, these different blocks are clusters, and I just took the most important words according to some metric to name these clusters somehow, and then all the members of these clusters, of these topics, are news articles with links to the Frankfurter Allgemeine, Spiegel, Welt, and so forth. And for each of these articles, you have a prediction that tells you the party affiliation. And it's not, so sometimes it kind of makes sense, and often it just totally doesn't. But that's one of the things that that I would like to have feedback on. I mean, if you have funny examples, that would be interesting, and also if Yeah, so it not always makes a lot of sense. This is the model that I trained on the political view prediction problem. So it's a bit simpler, and that's actually still, yeah, it's the simplest thing that I could do to deploy it. But it should actually be working. And what you get here is the manifesto code output, which is, well, it's a 56 class problem. In this pie chart here, most of the classes are so small that you don't see them. And then I deterministically derived from these labels here the political domain and, well, some left, right-wing binary kind of thing. And these can be interpreted as probabilities. So what I did here, I learned a lot about the language that the parties use. And this one here, if conservative parties talk about war, they don't say war, they say security. And this is a pretty, well, it's one of these sanity checks. You just enter security, you see it's right-wing, and it's, well. And other words that are as, well, good for checking where that author comes from is if somebody talks about banks or big companies, you can be pretty sure that it's a left-wing person. And of course, here the topic is economy, and it's pro-market regulation. And this is pretty much the same as before. It's just some topic modeling, and then in there you see the single articles and the predictions of the stuff that I showed before. Sometimes it kind of works, often it totally fails, but in some cases it's interesting what you actually get from it. At least you can get an overview over the news. And well, it's all open source, and here there's this. This is the name of the thing. It's derived from FYI, and it means for your political information. And the demo links are down there. So the remaining time I want to use to talk a little bit about well, what I tried in order to find out what this model actually did. So it's a linear model. Many people are tempted to just interpret these coefficients of this linear model just because the number of dimensions fits with the input dimensionality, and then they interpret these weights somehow. If you do this, you implicitly assume that all the features are uncorrelated, which is never the case for real data. So you should not interpret these coefficients, and there's a paper on this that explains this very nicely. So what you can do instead is just look at univariate correlation or dependency measures, and I just looked at correlations between the text features and the party labels, and these are the kind of plots that you can then get. So here you can just sort positive correlation, negative correlation, and I just looked at the top 10 or something. And yeah, so those can now be interpreted for each party by political experts, for instance. And also, like laymen, like me, for instance, see that, for instance, here the conservatives talk a lot about economic development or security, things like that. And the left-wing party, for instance, they talk a lot about social welfare, big companies. The Green Party talks a lot about army projects. They actually mention war, not as security. But there are other problems with the Green Party in the results. That's I think I haven't shown here, but there is a paper on this, and that's also on GitHub. So to summarize, these discriminative text features can be interpreted by experts. The Green Party, for instance, talks about defense projects a lot. They criticize it mainly. Left-wing party talks about social welfare, big companies. Social Democrats about the rights of the working class often. Christian conservatives talk about economic development. Now, especially the results on the government versus opposition classification and the poor performance on out-of-domain data, that maybe look at some other thing that I found interesting, sentiments of these parliament speeches. And well, the hypothesis is that, well, whether or not text has emotional, text has emotional aspects, and the question was, do different parties have different sentiment, or is there a dependency between political power and sentiment? And this is obviously a rhetorical question. I just took this sentiment polarity dictionary from University of Leipzig, and then I just computed the inner product of, I somehow weighted the text to compute sentiment. And these are the results. The parties are ordered according to the number of seats that they have in the parliament. And below I showed whether or not they are in the government or in the opposition. This is from the 17th Bundestag. And you can see on the y-axis now the average sentiment of a text. And you see the more seats, I mean, there's a strong trend for fewer seats, more negative sentiment, right? And now look at, so the FDP, well, it's a very neutral and liberal party, as you can see, but it's still slightly positive. Look at this party now. In the next parliament, FDP will not make it in the parliament, the liberals, so it's going to be only green, left-wing social democrats, which will then enter the government coalition. And look what's happening to their sentiment. So there seems to be a strong correlation between sentiment and political power. And when you just compute the numbers, so political power I took as proxy government membership, that's a binary variable, or the number of seats, and in both cases you get a strong correlation between well, the sentiment of the texts and the political power. So when I showed this to my brothers, for instance, they said, yeah, so what, that's super trivial, everybody knew this. And then, of course, then I only realized it's a super trivial result, but at least it's, well, a quantifiable thing, right? So it's not just an intuition. And sentiment is, as opposed to many other language features, very constant across domains. So, yeah, it's just, maybe it's a trivial result, but it might be useful for out-of-domain generalization. So to summarize, well, I trained some classifiers on parliament speeches and on manifestos, and political view or affiliation prediction works to some extent, and it gets more difficult for shorter and out-of-domain text, which makes sense intuitively. The discriminative features appear to be related to party policy, and sentiment analysis shows that more seats lead to more positive speeches in the parliament, which is probably pretty trivial. And government membership also correlates a lot with positive speech. And there are some other results that I found only last week or so that show that in the Canadian parliament, for instance, some similar effects. It's a two-party system there, and you also see that a lot of the information that the classifier is using is not related to the political agenda, to policies. It's more related to attacking the other political party or defending the well, yourself, right? So yeah, it's just most of these results are really trivial, but I found it fun to play with this, and that was only made possible by well, the open source community. I used a lot of well, pandas, scikit-learn mostly, and other open source tools. Yeah, thanks a lot. No, wait. Actually, there's some Outlook. Yeah. So I want to, of course, train on. This is all work in progress. I wanted to train on more texts, and then, yeah. Also, I want to look at this one here, and if anybody wants to collaborate on any of these, I'd be really interested in that. Thanks a lot.
Thank you, Felix, for the very nice talk. And we have now time for questions.
Yeah, thanks for the interesting talk. Really amazing project. I'm wondering, in the beginning you showed that found interesting that you reduced this 5-class classification problem to like 2 classes. So I'm wondering, you can achieve more or less the same accuracy if you take into account the imbalance between the labels, right? So like they only talks about half as frequency as
I did. You can do that in many ways.
Can you repeat the question?
I'm sorry, thanks. So the question was, so I showed that the classification accuracy went up by reducing the problem from a 5-class to a binary problem. I'm actually not sure, and then the question was whether I could achieve the same effect by balancing or taking into account the class imbalance. Because of course, in a parliament, the people in power have more time to speak. So the short answer is, I did that. So so all the models I trained, there are several ways how you can account for imbalance in your classes. Simplest one would be to just subsample and then make sure that you have the same, like a balanced set of classes. What you can also do, and this is what I did, is just take that into account in the regularizer of your model, and that's what I did. It's just standard implementation in scikit-learn. And so I'm almost sure that I didn't suffer from class imbalance here. But then I also don't know whether the increase in performance in that binary problem, by going to the binary problem, is, I mean, chance performance is also better, right, in that binary problem. So I'm not actually sure how much better I got. I didn't compare that, but maybe I should do that. That's a good point.
Any more questions?
Yeah. So your feature vectors were TF-IDF, is that right? So they'd be very high-dimensional, like the length of your vocab. Have you tried doing dimension reduction?
Yeah, didn't help.
Didn't help.
I was interested in your prediction accuracy, well, all of the metrics went down when you tried it on the out-of-domain data. Do you have any intuition as to why? Is it just because the classifier didn't see the data, or is it? I would imagine that the parity line should kind of hold. I don't see why the accuracy goes down. Do you have any kind of explanation?
Yeah, so there are many explanations. Some of these explanations I tried to highlight in the last part of the talk. The language is just different. What the classifier is using and that was the sentiment stuff, right? Might not be related to the party policies at all. It's maybe just, well, I'm just trying to defend my party now and try to attack the government party, and this is independent of policies. Also, the party policies change a lot, and this is what we're looking into now with Paula Lehmann from the Manifesto project. Yeah, so parties write something in their manifesto, and after that there are the elections, and then people have to form coalitions, right? And sorry, I didn't show that, but one of the words that comes up really a lot so the Social Democrats, they often mention this contract that binds them to their coalition with the conservatives. So a lot of the things that they do when they are in power, just because it's a democracy, right? They have to change their policies, so it necessarily will become different from what they wrote. But yeah, that's the only training data I had, so
Did you also, you looked at the terms which are owned by some domain or manifest. Did you look at the ones which are a bit more indifferent, used by all parties? So you looked at the maximizing entropy of, for example,
sorry, can you repeat that?
So you have terms like Sicherheit, which is
Yeah.
mostly used by conservatives. But there are also terms which could be used by all parties.
Yeah.
So you're looking at the maximizing of the entropy, right? One candidate would be allocation, I found one. Did you look at that?
So the question was, so there are some terms like Sicherheit, which is indicative of or discriminative for one party, but the question was, I think, if there are terms that are kind of common to all parties. Is that right? Yeah. So I haven't looked at that specifically. It would be not very useful for discriminating classes, so I guess it would just be weighted down by the model. Is that right? Oh yeah, of course. I mean, yeah, to some extent that's taken into account by the feature preprocessing. So on top of the stop word stuff that I did, I also had some thresholds on the word frequency counts, if it's too rare or too, yeah, and some of this stuff is also taken into account by the TF-IDF normalization. So, but I haven't looked at that specifically.
In the beginning you said you didn't use the name of the politicians, but have you tried something like predicting the party of a politician based on his speech? So it would be nice to, if someone is a politician, should he better be in another party or doing some clustering, right? On top of that, like the Shannon distance for the politician space, who's more left-wing in a party, who's more right-wing, based on the
yeah. Yeah, so the question was whether I tried looking at classifying single politicians, because the underlying assumption is that, well, there's a spectrum of political views amongst party members, so there might be one party member that actually belongs in a different party. That happens. I haven't looked at this, but I did all these analyses. So these analyses were just replicating what I did before. Before I was using Friedrich Lindenberg's Offenes Parlament API. But that API actually allows you to do that kind of experiment, and that would be actually really interesting.
Would be cool before the next election.
Yeah, and then just send them an email, hey, have you considered changing the party? Yeah. Others?
I'm just wondering whether those texts that you're analyzing, the differences are probably quite delicate. I mean, you can't really judge from the quantity of certain words to which party that text belongs. And if I'm not completely wrong, I just looked up an interview in Vice magazine, and it links to a website which is I think by you and Dania and a couple of other people. They actually
Oh.
those programs in a web app. You basically look for like a similar part of the text from one party to the other one, which kind of suggests that you actually find some certain similarities between those parties. So maybe the bag of words approach is something that is actually, it has some natural limitations, which is really quite quickly when you've already done it.
Yeah, so in short, correct me if I'm wrong, the question was whether the bag of words approach is appropriate for that kind of problem, and I'm absolutely sure that it's not. So of course it's a very crude approximation to language. We kind of try and get some of the sequential or context features in there by using n-grams. I haven't, to my surprise, found that these n-grams are particularly useful. So what the hyperparameter optimization ended up with was 2 grams, bigrams. So it's not a lot of stuff that is in there, but of course, due to the stop word removal, the n-gram stuff also gets kind of distorted. So there are a lot of papers that look into more complex things, like for instance, you can do just standard NLP stuff, look at the, do POS tagging, look at the grammatical, the tree structure in the language and all kinds of weird things. And of course, like some things like word embeddings would also make sense in order to leverage huge, larger corpora and just add these features in there. From experiments with other data, I found that this doesn't really help a lot in most cases, but it's an open problem. And if anybody feels up to the task, doing more complicated models, I'd be really interested in your results.